Your right hand person.
Here I go. As I said, we're going to go through performance solution. So performance solution of a building is basically durability of the building, the specification, the capacity, how much it costs, etc., etc. So to get the performance, you have performance requirements. And to get performance requirements, you can have performance solutions you can have deemed to satisfy, all right? And they're worked out through various subsystems in buildings, which then you can formulate a fire engineering brief. Fire engineering brief is basically a smaller document than the fire engineering report, so it goes into more detail. Now, through this session, you're going to hear things like deemed to satisfy, concept design, quantitative, qualitative assessments, deterministic, verification methods. All gets very confusing, okay, for some of us. But I'm trying to make it as simple as possible. I'm sure if there's something which needs to be put right, I'm sure Boone or someone will jump in and help me. So we go through National Construction Code, and I've got a small case study which I can show you for a performance solution in a building in Adelaide, which I'm hoping, who's this? Liam is coming in as well. Let me just, there's another couple. Most of you BCA engineers today, I think you're probably going to learn something off me. So anyway, as I said, the fire engineering brief is a smaller document which makes up the fire engineering report. And that fire engineering report goes to all the stakeholders and goes to the fire service and all the rest of it. And they do their testament, expert judgment, all that type of thing is put into that fire engineering report. And I know that a lot of us in first fire business experience fire engineering reports because they form a basis now in our emergency management manuals where we just take what the performance solution is. We don't take everything out of there like Grant's model and all that type of stuff. So engineers, they're looking at occupant safety first in a building. Then they're looking at fire safety, as I mentioned in earlier. And then avoiding spread to other buildings and obviously avoiding damage as well. So four main criteria which they're trying to achieve. But there's a lot of things which are not necessarily addressed in the National Construction Code, which you've got to think about, like preserving the heritage value. It might be the corporate image, things like the interest of the community and the infrastructure around it, and environmental damage. It just goes on and on and on. So there's a lot goes into these fire engineering reports. As we said, we've got the compliance level, which is the performance requirements of the building, and you can achieve that with what they call the deemed to satisfy. So that's a prescriptive solution within the National Construction Code. So you just go and build a building with that, and you don't need a performance solution. But you might need a performance solution in place. Let's say if a travel distance, for example, is got to be 25 meters as for deemed to satisfy, and it's been taken to 35 meters, then they've got to put a performance solution in if they don't put another exit in. So it might be something like put a fire door in, sprinkler protection, extra smoke detectors, and then they will formulate this brief, which will then formulate a report, send it to the fire service, all the rest of it, and then accept it. You with me? Everyone? Good. So it's got to be at least deemed to satisfy provision, yeah, or a combination of deemed to satisfy or the performance solution. So you can have a combination of the two, but both of them together have got to be able to satisfy the performance requirements of the building as set out in the National Construction Code. So you've got a performance solution, as I said, deemed to satisfy or a combination of the two, and it's achieved by different verification methods, which is provided in the National Construction Code. You've got other verification methods like quantitative, qualitative, probabilistic, deterministic approach, comparative, or you've got expert judgment, or they can compare it with deemed to satisfy as well within the National Construction Code. So performance requirements they're looking at in international fire engineering guidelines, they recommend that you look at these set of subsystems. Okay, now these subsystems all work together. So you've got subsystem A right through to F, and it's all to do with fire initiation, development and control, smoke development, fire spread, impact control, fire detection and warning, occupant evacuation and control, and fire service intervention. And all those subsystems, they all work with each other. And next time I'm going to show you something very simple with subsystems of how fire spreads if you leave the fire door open, which will affect all those different subsystems. So eventually you could have that fire spreading and smoke spread because you've got the fire door open, which is going to affect the fire service intervention and the occupant evacuation and control. So it's very, very important. But I'll explain them in the next session when I get it together. So these verification methods, you've got a comparative or absolute approach, and it's when you compare it with another building. So it could be a building that another engineering company have done, and they've got a big atrium in there, and they've got some FEBs, and they've got wall wetting sprinklers, and they've got extraction systems and things. And BCA engineers go along and say, oh, that's a good idea. We've got this design of this new building. Let's have a look at that one. Yeah, makes the job a lot easier. So they know it works. Okay. And you've got comparative approach as well. So you can, where you've compared it to another building, exactly what I've just said. So you've got a quantitative analysis, which is very rarely used because it's probably the most appropriate. It brings together many experts and their expert judgment to gain a result to the problem. So an example of that is a single escape route, which is appropriate to the escape height due to the protection offered by the escape stair. So the building is sprinkler protected, the stairs are open and the outside, allowing passive smoke ventilation. Therefore, the stair would not become smoke lodged in the event of a fire. I told you it gets a bit confusing. So quantitative approaches, that's where you're using things like modeling for analysis. Okay, and this is just a simple CFAST model, which I got off, I think Nathan gave me that, and that's showing different compartments and where the smoke spreads to. So there's lots of different equations go into this modeling. They put in like the type of material burning, how fast it burn at, how much smoke is produced. That's all these computer systems, and you can see it moving through buildings on a computer. So one of these, a quantitative assessment of analysis, was to justify the removal of sprinklers to a mole. So this one was a mole in Adelaide, and they had roof sheeting. You can see it there. It was considered outdoor space in the event of a fire, so it had passive smoke vents, which are utilised for cool smoke or smouldering fire. So they didn't need to put sprinklers in that mole. And you can see here they've done some modelling to prove it to the fire service, and that goes in the fire engineering report. So there's a lot. It's not just that picture goes in. There's a lot of equations going there, and if you've seen a big fire engineering report, they're absolutely massive. So deterministic or probabilistic methods are most commonly used, and they're better developed in less complex. So they're used to assess the overall level of risk on critical parameters. The method analyzes and combines several different scenarios to gain a complete fire engineering evaluation of the building design. It requires a large amount of data and is very complex and time consuming. So some examples of contents, but not limited to, the fire engineering brief. There is a lot more. Obviously, you've got to put the purpose in there. You've got references to National Construction Codes, Australian standards, things like that. Exclusions, things like air conditioning will probably be excluded from it, BMS systems. And then you've got to put the regulations, building description and characteristics. So what sort of building is it and what type, where it is. Occupant characteristics, what type of people are in there? Are they mobility impaired? Is it a care home? Is it a hotel? Has it got sort of, it could be a home for people who've just come out of prison, so which means they might be on drugs or alcohol induced. Non-compliance issues for hazards around it and inside it, and they put a worst case scenario inside the fire engineering report. Trial concept designs and methodologies, modelling, and the outcome of that fire engineering brief, and that will then go together and make up the fire engineering report. So this is one which was one that they did in Adelaide, where they wanted to remove the hose reels from all the floors. Now, the deemed to satisfy provision said it must have home reels. It must be located in 4 meters and exits and would provide coverage to all parts of the building or floor. Okay. So performance requires that they're saying, these ones, the fire hose reels are only installed on the ground floor, and they will fit in accordance with the BCA 2005 and AS2 441 installation of fire hose reels. They're not installed on any other floors. The brief states that additional fire extinguishers are distributed throughout the office levels to supplement the deletion of fire hose reels. The fire extinguisher fit into 444. And that they state and selection and location as the deemed to satisfy the BCA states. So performance requirements of those, the hose reel system must be installed to the degree necessary to allow occupants to safely undertake initial attack on a fire appropriate to the size of a compartment, the function in use, any other fire system installed in the building, and the fire hazard. So that's the deemed to satisfy requirements. So they deemed that fire engineering report put in there that you remove the hose reels and they're going to put extra extinguishers in there to cover for not having the hose reels. So the justification for it was they got fast response sprinkler heads were installed. And they're saying the time of activation of the sprinkler is approximately time of that required for an occupant to identify a fire, locate the hose reel, read the instructions, and will unwind the hose reel from the drum. So what they're saying is that sprinklers would go off quicker, really, than someone would be to find a fire, locate the hose reel, read the instructions, and unwind it. Really, as I've been saying before, you shouldn't be using these things if you've got to read the instructions before you use them. You should know how to use them just straight at the top of your head. So there's many maintenance implications in those fire engineering briefs. So that's where we come in with first 5 minutes. That you have a look at the brief. Yes, it said take the hose reels out and they put extinguishers in. Now the problem you get, or you did get a few years ago, is some buildings went into didn't know whether there was a fire engineering solution in there, something like this. So where they took out the hose reels and put extra extinguishers in, a few years down the line, you could get a new property manager come in, or facilities manager, and a new maintenance company, and not knowing about this fire engineering brief, saying they want extra extinguishers, and the fire maintenance company could say to the property manager, I can save you thousands in here on maintenance of fire extinguishers because you've got too many. We don't need all these, and they take them out, which yes saves them money, but they've gone against that alternative solution. So I think it was about 2005 or 2006, they came up with green stickers on the fire indicator panel here in Adelaide. And the fire engineering solution had to be put on the back of the block plans. So the other thing as well, in the fire engineering brief, it also said that extra training should be provided every year for occupants in the use of fire extinguishers. So that when we go and do quotes, is we're saying, well, they're saying all occupants in this fire engineering brief needs to have training on fire extinguishers, not just your ones. And that building actually we did do, and we did quite a bit of hot fire training. So that's it, guys. Has anyone got any questions? If you have, ask the engineers. Go on in, Mark. Voice on, Mark.
Yeah, just waiting to come off mute.
My finger's a bit slow.
Awesome job, Nick. It's and welcome to everyone. It's not very often we get a chance to interface with fire engineers, although I've read many of their reports. And but a couple of questions that I have, hopefully that leads to a simple answer without delving into DTS, etc. Aged care facility, occupant warning system is set to 0 cascade time. No alert tone, evacuation is implemented immediately, causing chaos. My simple recommendation was consult a fire engineer. Maybe it needs a building permit issued to have the alert tone initiated and a reasonable cascade time until the evac signal. And that particular organisation have met roadblocks after roadblock, and they've pretty much given up. Is there a simple way to have that cascade time altered?
Does one of the engineers want to answer that one, Boone, or someone? Because I've had Nathan do exactly the same for me in some buildings here. Hello. There is a simple way of doing it. Engineers go in, like Nathan's been in and done a few here with me in Adelaide, and they give the building report. And
this particular one, the engineer, who's apparently a long-term associate, has said, obviously the occupant warning system was installed to the 2004 standard, and the wiring in the building is insufficient to support an extra tone.
Right, so that means it needs rewiring. Maybe Alex, I noticed you on here. Alex is one of the directors of BCA. Very good engineer. I've been out with him a few times in buildings. He showed me a lot of stuff. So, Alex, I wonder whether you could answer that one, could you?
Yeah, can you guys hear me?
Yeah.
Yep.
I'm in my car at the moment, so
Right.
bear with me. But yeah, you should be able to at least look at, even if you can't do 2 tones, which surprises me that it would need to be rewired. But even if you can't do 2 tones, I would imagine that you'd be able to put some sort of delay on it, perhaps like an alarm acknowledgement even, that should be able to be approved by everyone, including a certifier and the fire brigade if it needs to go to that level. But I don't see any reason why you couldn't do that.
Yeah, that's my thoughts as well, but I'm not a fire engineer or a building surveyor, so I sort of know my place in the world, and that sort of answers exactly. I know that I am on the right track. I just needed that reinforcement. But one other question, and I suppose it's relevant to all capital cities, and Nick, you've got your hand well and truly on WA and SA, but here in Victoria, we have a lot of our older buildings that are equipped with lay flat hoses. And when we're going into the buildings, the lay flat hoses are still installed, hanging, most times not as per the standard, or in some circumstances, fire hose reels have been retrofitted, but the lay flat hoses are still in situ. And my long-term advice to clients, consult a relevant building person and have the lay flats removed. They're no longer supported. But just under having that quantitative guidance from the people here, so that I can pass on to our consultant team when viewing these things in buildings as to what we need to advise our clients on.
I would always advise them. I wouldn't say take them out myself personally. I'd go to someone more qualified. I'd go to, I normally use BCA engineers. I go to Alex or Nathan for anything, and if they need a report, then they will just send a report and recommend the removal of the lay flat hoses, for example.
Okay, cool.
But they'd have to do an assessment, and they would get, they take the risk. They know exactly what's going on.
Exactly right. At least, our clients can be pointed in the right direction, because they're still paying for the maintenance of these lay flats that are not going to be used.
No, that's right.
Hmm.
But yeah, they are in Melbourne anyway, BCA. So you might want to catch up with some of them sometime.
Yep, cool.
I
Thanks.
would imagine it would be appropriate to remove them because the fire brigade isn't going to use them. They wouldn't trust them anymore. So it'd be easy to justify removal of them from any building.
Excellent. Thank you, Alex.
Is there anything else, guys? Thanks, Alex, for that. So next week or week after, I've got a couple of big presentations I've got to do in the next few weeks. So it might be a few weeks later, but I'm just going to go through the relationships of those subsystems so you understand. I'm just going to give you a simple example of a fire door being left open and how it affects all those subsystems. Okay, and it's something very simple which you can actually take to your people in buildings and explain to them in simplistic format of how a wedge in a fire door can affect the fire and smoke development and the fire detection and occupant evacuation, and ultimately the fire service intervention.
So, Nick, us being in Queensland, you're still doing this session?
What do you mean?
Well, next Friday.
Oh, no, I won't be doing it next Friday. No, I've got too much going on next few weeks. I've got a big presentation to the FPA on the 20th of this month as well, because we're doing this case study in a building, doing evacuation. They're taking videos and things. Myself, there's Nathan Brown, Alan Short and myself are doing a presentation on cladding in buildings and whether we can have the same sort of fire as there was in Grenfell Tower, whether that could happen in Adelaide. So we're going from the design to the maintenance to the evacuation procedures.
Excellent. Forward to seeing it.
Okay, guys.
Thanks, Nick. Really appreciate it.
Everyone happy? Does any of the engineers want to add anything in before I go on this subject? No?
Very few words, a lot of action.
I'll take it was okay then. So thanks for your input, guys, and I'll see you next time.
Thanks very much, Nick.
Thanks,
Cheers,
everyone.
guys. See ya.
Thank you.
See ya.